Okay, hi everyone. Welcome to the pre-recorded lecture for Class 5. This week we're going to be talking about parallel spaces, the type of spaces we see in traditional Chinese scroll painting, in a lot of architectural drawings, and in a lot of computer games. The agenda for class today is, first of all, you should have watched the Class 4 Blender exercise online and uploaded some rendered images to Moodle before class. So in class we'll have a look at those images as usual and see if anybody had any problems or any interesting or beautiful images that you made. Then we'll talk about this lecture on parallel spaces, and then in class we'll have a student-led discussion of Jan Crick's text Axonometry, a Matter of Perspective. I will then introduce the next 3D modeling task, which will be animation and rendering. And we will also discuss the theory presentation assignment, which is coming up. Okay, so the most recent Blender exercise we had last week for Class 4 was UV unwrapping and texturing. So by now you should have UV unwrapped and textured your Babel library monomer, arranged and sewn the UVs into a logical order, made a shader and applied textures, and rendered and saved some images, and with any luck we should have some lovely images to look at in Moodle. Okay, so on to the lecture, parallel spaces. So last week I introduced a few different artists, two of whom use parallel spaces in their work. Paul Noble uses Oblique Projection in the construction of Nobson Newtown, and Sunwoo Hoon and Mijun Pak use Isometric Projection in their work Flat is the New Deep. In my own work, I've used Oblique Projection many times, and I use it often to create multi-screen video animations where the landscape can be continued endlessly by simply adding one more screen and adding one more piece of landscape, which, as we will discuss in this lecture, exploits some of the unique properties of parallel projection systems, which have many of their historical origins in Chinese scroll painting. This is also an image from my own art practice from some years ago, in this case also using oblique projection to make a sort of disjointed yet endlessly extendable world where in some way drawings can be joined up together or rearranged into a different format. This video is from another older work of mine. In this case, I was using an orthographic camera in a computer game to create some sort of strange clipping and spatially confusing environments. I think we already discussed in class the Penrose steps illusion and the drawings of MC Escher and how parallel projection systems can be used to great artistic effect in creating kind of spatially confusing environments. So the lecture from this week is based around a text by the author Jan Crick. Jan Crick has written on a number of fields. He also writes on cybernetics and Chinese philosophy. I've used this text by him, Axonometry and a Matter of Perspective, a number of times. I haven't read his monograph, which is pictured to the right, but on that topic, of course, locally here to Hong Kong, I can highly recommend Professor Yu Kui's The Question Concerning Technology in China, an essay in cosmotechnics. Okay, so the spatial systems that we're going to be talking about today are mainly oblique projection, which we see on the left, and isometric projection that we see on the right. Jan Crick talks about how the spatial structures of various computer games link them to pre-existing traditions of visuality. The relevant thing to us here is the common use of parallel projection systems in real-time strategy games or in architectural drawings, and their precedence in Chinese scroll painting, and how we see combinations of these ideas in a number of contemporary works today. Both of these drawing systems fall under what is known as the parallel projection class, due to the fact that when these spatial drawing systems are used, all parallel lines on the object themselves remain parallel on the image, and they never converge to a vanishing point as we would expect in a perspective-based drawing. One of the advantages of this is that usually, no matter where other figures like humans or trees or any other object appear in the image, there's no scaling. So figures don't have to get larger and smaller as they move around the space, which means that we can do all sorts of interesting things with drawing and painting and animation and computer games and the moving image. Due to the lack of this first-person perspective in both oblique projection and isometric projection, they lend themselves very well to the point of view of an overseer, or what is referred to in computer games as the God mode point of view. Chinese scroll paintings historically, as you most probably know, can unfold on either the X horizontal or the Y vertical axis. Those scrolls that unfold on the horizontal X-axis often allow the use of an endlessly extendable parallel space, which can then become the medium for communicating journeys or historical explorations of landscapes or territories. The image currently shown on screen is a section of the scroll painting depicting the southern inspection tour of the Kangxi Emperor during the Qing dynasty. This scroll was commissioned to document the extensive travels undertaken in the early decades of the Qing dynasty, and these tours taken by the Kangxi Emperor were of immense symbolic importance for the early Manchu dynastic rulers. At that time, southern China was an immensely productive agricultural region, but it was also the home to the literati cultural elite. In southern China, the maintenance of flood levee systems was very important to maintaining the political legitimacy of the Manchu dynasty, which was connected to their demonstrating their cultural right to rule China. So, to commemorate the southern inspection tour of the Kangxi Emperor, a series of scroll paintings headed by the artist Wang Hui depicted the inspection of the levee systems, as well as the Kangxi Emperor observing Confucian rites at a famous shrine. In addition to depicting events of geopolitical significance, Wang Hui's scroll deploys elements such as the blue and green mountain colour scheme, which is reminiscent of the Tang dynasty, and the scholar's pine trees, reminiscent of the movement begun by elite scholar artists in the Yuan dynasty. Both of these elements charge the actual events depicted in the landscape with additional layers of cultural metaphor. And from the perspective of spatial construction, the extendable length of the scroll functions as a tool for looking at themes in narrative and geography. As we move through the space of the scroll, we move through the geography of Qing Dynasty China, and through the social, environmental, and political features all packed into this sprawling landscape. And in this illustration, this time from Qiao Ying, from a Ming Dynasty scroll, I've drawn on top just an indication of, again, this parallel grid asserting itself within the way that the architecture of the scroll is structured. And as mentioned in Jan Crick's paper, parallel projection systems, in the case of this short video, isometric projection, also has a very long history in computer games, as we will discuss when we talk about the reading in class. Whilst this may have begun as an innovative solution to certain limitations in computing power, isometric space spawned a whole genre of games that take advantage of just how easy isometrics makes it to do things like designing cities or commanding large armies, all these sorts of things that are really not so well suited to perspectival space. So again, in this case, I've used a screenshot from StarCraft 1, we can see that just as underneath the Chinese scroll paintings, particularly in the architectural academic style, there was this gridded space. In isometric games, it's much the same. Underneath the game, we can see these parallel grid lines structuring the isometric space of the game. So to be very specific, parallel projection systems have a few rules. For a start, there are no vanishing points in parallel projection systems, and all lines remain parallel. Therefore, objects that are the same size in the real world are all the same size in the drawing. They never get larger or smaller as they move around the space. And the benefit of this is it allows for these endlessly extendable spaces. So if we think back to Paul Noble's work with Nobson Newtown, by using oblique projection, he was able to endlessly extend his worlds without having to worry so much about the scaling of every object relative to where the vanishing point in the picture would be if it was a perspective image. And we'll talk about some of these details historically a little bit more when we have our student-led discussion of the Jan Crick reading. So, isometric and oblique projection fit into a much larger family of spatial construction systems. And in our class exercises this week and next week, I'm going to get you to draw some of these yourselves. The main difference for us is we're looking at the difference between, on the left-hand side, these parallel projection, compared to, on the right-hand side, these perspective projections. Perspective projections we're probably more familiar with. It's the use of a vanishing point, and it's the sort of view that is typically created by a camera. And we'll talk about perspective projections a lot more next week. But usually when we take a photograph with the camera on our phone, or most default cameras that we use in 3D programs like Blender are usually perspective-based cameras. And that means that somewhere there's a vanishing point and we have this spatial warping where things that are closest to the camera are large and things that are further away from the camera are much smaller. So the opposite to this would be the parallel projection systems that sort of dominate the left-hand side of this slide. We are mainly looking at oblique and isometric systems, and when you see all of these other names like dimetric, trimetric, cavalier, military, these all have slight mathematical differences, and it's usually because they derive from slightly different industries. Cabinet projection, as is suggested by the name, has its origins in furniture construction, and it usually involves a compression on the depth axis such that everything on the face that is facing the viewer is drawn to scale, and everything on the face that is on the oblique angle to the viewer is compressed by 50%. And this might just be so that, say, a piece of furniture or a piece of architecture can fit on the page, whilst still allowing the drawing to convey accurate measurements. So most of the parallel projection systems often have very industrial uses because we can preserve measurements. For example, on an isometric diagram of a piece of machinery, a lot of the measurements on the drawing will actually be highly accurate to the measurements of the object in real life. And this is one of the sort of mathematical reasons both that industry and computer games and computer graphics found parallel projections to be very useful, because the mathematics is quite simple compared to the complex scaling that we see in perspective projection, where we have to calculate things to be constantly getting larger and getting smaller. So this week when I get you to draw in parallel projection, you should find that it's actually quite easy once you get started. We don't have to worry so much about how everything fits in relation to the vanishing point. So these are sort of little previews of how we might draw in some of the projection systems. In this case, we're looking at isometric projection. And isometric projection, the main feature that we'll notice is that in the case of this building I've drawn, neither face of the building is parallel to us, the viewer, or parallel to what we call the picture plane. If we think about the piece of paper as sort of a piece of glass in between us and the world of the drawing, no faces of this building are parallel to that piece of glass. They're both going off on an angle. And if I just skip to the next slide, we'll see that that angle in isometrics is usually quite consistent. We're usually looking at an angle of 30 degrees off on both sides of the building. So if I've just sort of photoshopped a protractor on top of this image, and we can see that both sides of the building are projecting off at a 30-degree angle from the baseline. One of the benefits of isometrics, as I said before, is it's fantastic for repetition, tiling, and having a sort of spatial God view overview of a world. It's why we see it so much in games like SimCity or City Skylines or other games that allow us to build large architectural worlds. Okay, so in Oblique Projection, now we can see that something's changed. Now we have one face of the building is parallel to that imaginary picture plane, that imaginary piece of glass between us and the world of the drawing. The front face of the building is parallel. So that means that all of the angles of the windows here are at 90 degrees, and it's only on one side of the building that all of those 90-degree angles cease to be 90 degrees. So if we look at the protractor this time, we're looking at an angle usually of about 135 degrees, being the difference between the horizontal of the front face of the building and the diagonal of the oblique side of the building. And oblique projection gives us the same benefit that we see with isometrics, that we can copy and paste and tile these buildings. We can turn this little building here into a tower block simply by copying and pasting them up, because we don't have to worry about the changing of scale and perspective. One interesting computer game I can really recommend that uses isometric space in a very abstract way is Molla Industria's game Nova Alia, and you can download this game for free and play it. It's quite short, I think it goes for about 5 or 10 minutes, but it really uses the abstract city building function of isometric space to tell a story about urbanism and the kind of finances and sociological phenomena of gentrification and property investment, but just through using a very simple storytelling technique that takes advantage of isometric projection. Okay, so for the exercise this week, what I've prepared for you is a pre-made Blender scene that has lots of different elements that you can transform for yourselves, and I will upload a tutorial that demonstrates how to explore this scene, and all of this scene will be downloadable on Moodle. And I want you all to make a short animation using either isometric or oblique space. So in the video I also show you how to switch from isometric to oblique spaces, and I want you to explore for yourselves how you can use this scene that I've set up for you to make a short animation taking advantage of the parallel extendable nature of this type of space. Okay, that's it for the lecture this week. I look forward to our discussions in class, and I'll see you soon. Bye-bye.